Okay, for the final video of the chapter, we will do an example, maybe a counterexample, and then we'll look at a couple of simple theorems. The first is an example problem where we're going to suppose we have a circle C that has a center O, and it has two chords A, B, and C, D. Prove or disprove. So we don't know if it's true or false yet. If CD, that line segment, that chord, is twice as far from the origin as is AB, twice as far away, then AB is twice the length of CD. Okay, if CD is twice as far away, the farther it gets away, the smaller it gets, right? This chord is the biggest it could get, from here to here, because it's a diameter. As you move away, it gets smaller and smaller. So if CD is twice as far from the origin as AB is, then AB will be twice the length of CD. Okay, let's consider a circle in the xy plane, where here is the origin, 0, 0. And on the x-axis, we have negative 10 and 10. I guess I should have said, this is the circle. The radius is the square root of 100, which is 10. So this would be 10 as well, and this would be negative 10 on the y-axis. Okay, so just for example, draw the vertical chords. Remember, vertical lines are always x equals a number. So if this is x equals 6, half of that distance, this distance is 6 right here. Half of that distance would be 3. There we go. 3 from there to there, because this is negative 3, and this is 6 right here, and this is 0 on the x-axis. Okay, well, let's now draw triangles. Connect that, and do the same thing over here. Now, one thing we know is that the radius of this circle is 10. So we have this is 10, that length 10, that length is 10, this length is 10, this length is 10. All right, so let's label some of these points. We'll call that one CD, call this one A, B. All right, so how long is CD? Well, do you know this by heart? Remember, there is a 3, 4, 5 triangle, right triangle. Well, this is a right angle. So this is going to be 6, 8, 10. Just double the size, the lengths of the 3, 4, 5. That's going to be 8. So we know that CD is equal to 16. The length of this chord is 16. Well, it certainly looks like it's going to be false, because this chord is not going to be twice as long as this one. But let's go ahead and figure out what it is. AB is going to be, let's see, it's going to be twice the length, this length here. So 2 times, and what is this length? Well, using the Pythagorean theorem, we have 3 squared plus this squared is equal to 10 squared. So it's going to be 10 squared minus 3 squared under a square root. Okay, again, that's just using the Pythagorean theorem. And this is 2 times radical 91. And let's see what that is. That's approximately 19. So clearly not true. If this statement were true, so we just disproved it with our one single counterexample. The chord CD is twice as far from the origin as is the chord AB, but it is not in a ratio of 2 to 1. As a matter of fact, they're pretty close. 16 and roughly speaking 19. Okay, so that was a simple, disprove is always easy if it's false, because you just need to find one counter example. All right, recall, a tangent is a line that meets a circle at one point, just touches the circle at one single point, whereas secant is a line that crosses it twice at 2 points. So here's our theorem we'll call the tangent theorem. A line is tangent to a circle. So let me draw a line that is tangent to the circle at that one point. If and only if it's perpendicular to the, let's see, if and only if it is perpendicular to what? Well, a radius. The radius at the point of contact. We've seen some theorems that look something like that already. So what that tells us is that's a right angle. So you take a tangent and you drop a perpendicular at this point of tangency where it's touching the circle, and you're going to get a radius out of it. Go right up to the center O. Okay, 13. Here's a corollary. We're going to take two tangents this time, but two specific tangents. Two tangents, PA and PB, where A and B are on the circle. So start off by putting a point P out here, like that. Now, there are two ways to make a line that goes through P and is tangent to the circle. One of them is like that, and the other is like that. Okay, so you have two tangents to the circle that go through this point P. We'll call this one going through A. We'll call this one going through the point at B. All right, so two tangents to a circle with center O. So put the center somewhere there. From a common endpoint, that's the P, have A and B as points of contact with the circle C. Then PA is congruent to PB. And one more thing. PO, that ray, bisects that angle, the angle APB. Okay, so that means that this angle is the same as this angle because it bisects the angle. Kind of have two half angles there. All right, last one's quite easy. Secant theorem. If a line L passes through an interior point A of a circle, so remember what an interior point is. It's not a point out here, it's a point in there. So a line that passes through that is by definition a secant. It's a line that passes through a circle twice, and therefore it intersects the circle at precisely how many points? 1, 2. Once again, a tangent hits a circle or touches a circle at exactly 1 point, but if you take it and move it a little bit, so it crosses a point on the interior of the circle, that line is going to become a secant point, and it'll cross it 2 times.